Collab is kind of a workaround to make this easier. So we are currently copying and pasting all of the dependent files into the one notebook. So it's just one massive string of code, which if you have it in your on your local environment, it won't be such a long block of code because you're pulling in dependencies from the Git repo. So if you're a cadCAD power user, I would say it's worth the hour or two setup to get your local cadCAD environment on your local machine. If you are just dipping your toes in and want to see how cadCAD works, then the Google Collab link in the workshop discussion channel is for you.
Okay, I would like to set up my environment. Well, what do I do?
Cool. So Tyler and I actually went through this process just a couple of weeks ago, so he's quite the expert, so maybe he can take over and walk you through some of the process.
Yeah, I can do that. What operating system are you on?
I'm on Linux, Arch Linux, Manjaro.
Okay. Do you have an existing Python environment set up?
I have an existing cadCAD environment set up, but it's using cadCAD 3.
Okay.
Whatever, the previous version. Yeah.
The previous version. 0.3 or whatever. Okay. Is that a vanilla sort of Python setup, or are you using something like Conda or virtual environments to?
I'm using virtual env wrapper. That's all.
Okay. So yeah, so you could technically use that and just create a new environment and then do a fresh install of cadCAD using pip if you wanted. I think that would grab the latest version and kind of have it segregated into its own little virtual environment. The actual install using pip is pretty easy. Just pip install cadCAD. You can specify a version too when you do that. It sounds like you might already be ready to go, aside from running an older version. If we can just get the new version installed for you, I think you're good to go.
Okay, so all I have to do is run pip install cadCAD, and now I have cadCAD 0.4.17, and that's it.
Yeah, you'll actually also want to install the Jupyter Notebook as well, and I can't remember what that package is called. I want to say it's Jupyter-Notebook.
Jupyter is it? That's just Jupyter.
It's just Jupyter. Okay. Yeah, so you'll want that installed too, so that you can actually run the local Git repository as a notebook. And I think that's it. Jeff, there wasn't anything else that we had to install, right? I think that was it.
I think most of the other things we were doing were just glitches on install. So as long as you can run
it was just getting your Python set up.
Yeah.
Yeah. Yeah, on Windows it's a little bit funky. So, but yeah, you got a good setup for it. You should be pretty much ready. Are you familiar with running the Jupyter Notebook backend?
Yes,
Okay.
But where is this repo that I have to clone?
Yeah, it's in the, if you scroll up from the voice channel there on the left, there's an actual chat channel called Workshop Discussion. Yeah, and it's one of the last or most recent links that was posted by Jeff.
I think I'm gonna push an update to it before we start because I found something that I wanted to swap in the setup, and so I would suggest that you wait maybe 5 more minutes before you pull it, because I was going through it with Andrew and we were like cleaning things up for this workshop, which is sort of for reference. It's in advance of sort of pushing some more like final versions to this repo in the next week or so, and so we're kind of we're doing work on the repo at the same time we're using it as the source for the workshop. So you just have to bear with us while we get it ready to go for 20 minutes from now. And I'll make the last push in the next few minutes.
Yeah, just let us know here when you do, and then we'll be able to safely.
I had very much intended not to do this after 2:30, but the thing I found was very recent, so I'm just it has to do with. I'll end up explaining it during the discussion, and it'll be fine. But
Cool.
Thanks.
Yeah, so just to recap for everybody, the next 20 minutes is kind of a pre-workshop setup. So if anyone is interested in installing a local cadCAD environment, Tyler here is quite experienced in helping set that up. Otherwise, there are some links in the workshop discussion channel just above to the Google Colab version and also the repo, the GitHub repo that we will be working from. And there are a few more pushes coming in the next few minutes. So if you could just hold tight, if anyone is interested in installing a local cadCAD environment, please feel free to speak up. Otherwise, we're just doing some last touch-ups to the repo, and we'll start at 3 o'clock PST, 6 o'clock EST or EDT, whatever daylight time, I guess.
Hey Jeff, do you know if Zargham's going to be? Is he going to be working out of the Git repo, or is he also going to be using the Google Collab?
I'm going to be in VS Code. But I'm going to give a short, when I get on, I'm going to talk a little bit from some slides and then pop open VS Code and look at notebooks and the .py files.
Okay.
Yeah, so the Collab is just for people to follow along who don't want to go through the local environment setup. But there will be some shared screens, and we'll be doing most of the work in the repo and a couple of slide presentations as well.
Just as a bit of a warning for anyone who might be interested in potentially getting set up with cadCAD on a Windows install, make sure that you don't install the Python package that's available through the Windows marketplace. It's garbage. It doesn't work the way that it should out of the box, and it'll end up causing you more headaches than anything. So I definitely recommend just heading over to the Python, website directly and downloading one of the Windows packages from there and installing. Once you have that installed, getting set up with the Jupyter notebooks and the cadCAD engine itself is super trivial.
So Tyler, it looks like you can set up Google Colab to import from other .py files. I will just drop this link Maybe I'll drop it to you in Slack just because I don't think it's relevant for the overall.
You can also do direct messages on Discord if you wanted.
Oh, cool. Yeah.
How are we going with the push? Can I pull it yet?
Not yet. I'm about to do it. Sorry, I was updating the notebooks, and the notebooks take a few minutes to, or not a few minutes, but they take a moment to run. So I'm checking them right now, and if they're good, I'm gonna push it.
Awesome. Thanks, man.
And should we be using the workshop branch or the like master branch with the workshop copy like folder?
We're merging it into master. That way, the workshop branch I was originally going to have people pull off of, but we ended up making a separate folder for v2-workshop copy. So you'll be able to use that in master, and that will preserve the version that we used in the workshop. Even if we continue to clean up v2 and make the v3, there will always be in master a copy of the one we used for this, so that if people are like looking at the video or something, they can actually pull the code that we used.
Nice.
So master branch, but the v2 workshop folder.
Correct. Sorry. I'm going to divert my attention back to getting this pushed for you guys, though, because I need to check these things so that I can throw it up there and then everyone can pull. In my head, I was working, I'm trying to get ready to go for the live stuff starting at 3, and I'm, apologies for the delay on the infrastructure.
And for all those Google Collab folks, I will actually drop in this Medium post about which is a beginner's guide to Google Collab. If you're interested in using this tool to do cadCAD stuff in the future, that seems like there's some useful setup functions in this article here, just for anyone who's interested. For any new joiners, I'll just reiterate that we have 10 minutes left in our pre-workshop cadCAD setup. So if anyone is interested in setting up a local environment of cadCAD, please feel free to speak up, and Tyler can help you get set up with cadCAD on your local machine. If you are just interested in dabbling your toes in the workshop discussion channel just above the voice channel, there is a link to the Google Collab, which is kind of a Google Docs version where you can play with cadCAD and understand the functionality. And we'll be starting the workshop in just about 10 minutes.
I can also tackle install help after, if anyone would prefer doing it after the actual workshop too.
Sorry, I came in a little late. And so do I just go to the repo? Where do I start?
Yeah.
Where to download? Okay.
Yeah, it's pushed. So why don't you do a walkthrough, Jeff and Tyler, just from the start for the last 10 minutes? Just review how to get people set up once as a walkthrough, and we'll start with Luke's talk at the hour. But we're good. The bug fix I had got pushed just now.
So the process is pretty simple. There's going to be a little bit of nuance depending on the operating system and your Python install environment. But the basic gist of it is to get a fresh Python 3 install working on whatever system you're using. And then using pip, you will want to install the Jupyter Notebook package, and you'll want to install cadCAD. Once you have those two things installed, supposing there's no weird problems or issues that arose, you should be able to do a git clone on the Git repository that Jeff has posted in the workshop discussion channel. And once you have that repo cloned, you can just change directory into that repo and go into the, I believe it's called V2 workshop copy. Go into that directory and start your Jupyter Notebook server within that directory, and that should get you the same sort of setup that Z's going to be working with, minus the VS Code that he'll be using.
Got it. That makes sense. I'm on it.
Okay.
Thank you.
Yeah, if you have any issues, just let me know. You can private chat me during, like if they get started before and you still don't have it figured out, you can message me privately, or you can just follow along with Z, and then we can get you set up afterwards too. Whatever's
Cool.
easiest.
Awesome. Thank you so much. And then there's that Google Collab that I'm not familiar with that. That's an alternative way of being able to like.
Yeah, it's a hosted Jupyter lab basically, as far as I understand. So, but it's kind of in a broken state right now, unless Jeff has made some progress in the last few minutes. But we've basically taken all of the individual Python modules and individual files. We've just kind of dumped them into a single Python notebook or a Jupyter notebook that you can follow along, and you've got all the code there in one place. So it's, yeah, it doesn't require any setup.
Got it. It's like a cloud IDE that is just hosted on a server that I can just like start running with.
Yeah, essentially.
Cool. Thank you.
Yeah, and I think the Google. Sorry, go ahead.
No, I was going to ask if you can share the pip command that we need to install.
The command
Share the what?
The pip Jupyter command that we need to install for Python. I didn't get that part.
Just pip space install cadCAD. That should grab the latest version.
Pip space install space cadCAD.
Correct. And then you'll also need to do a pip install for, I believe the package is called Jupyter Notebook. It might just be called Jupyter.
Okay.
I think a nice touch might be to sometimes in Jupyter Notebooks you can put the shebang pip3 install command in the notebook, so that might be a nice little touch. Just to make it, just go to the Jupyter Notebook, and when you get to the part on step 13 or whatever it is, cell number 13, where you import the module, just have a commented out shebang at the top that says pip3 install. I think that should be pretty obvious.
Yeah, that's a good idea. Yeah, I know we do have it on some of them. Don't have it on everything though.
It's kind of funny playing with your own project because you guys probably use cadCAD every day. So for you guys, it's not intuitive or obvious. Oh, well, you got to install it, so you're forgiven.
Yeah, definitely. This is a collaborative learning process. I mean, the Block.Science are definitely the experts on cadCAD, but cadCAD as an open source community is just coming together. So all of the collective learning and all of the suggestions are much appreciated. So thank you very much for that. And I guess
of onboarding, that's definitely something we want to make that as frictionless as possible. So if you've got ideas on making this entire process easier for people, by all means, say something and we'll do our best to get it in place.
Awesome. So we are at 4 o'clock. So this is the conclusion of the pre-workshop cadCAD setup session. So if Luke, if you are still at your computer, maybe we can start off with your introduction of cadCAD as used in OneHive and the OneHive DAO on XDAI, and then we'll follow up with the workshop from Michael Zargham walking through the conviction voting notebook and getting our hands on some of the Python code.
Can we make sure if we have a recording set up that we get it kicked off? I know I'm pretty sure we weren't recording the sort of general help setup discussions, but it would be good to record from here out.
Yep, I've started on my end, and I believe we have another one recording from Peath already, so we should be double covered.
Awesome.
Yeah, Peath, will you drop that YouTube link in the workshop discussion channel for me to spread in other places?
Will do.
Cool. Can you guys hear me? And can you see my my screen?
Yep.
Awesome. Cool. So I wanted to kind of give an overview of kind of how OneHive is using conviction voting and like why we're super excited about it and why we're kind of like rushing to build an MVP and just start dogfooding. So like most kind of people in the DAO space, we really wanted to find a way for people to come together from all over the world, build things collectively. But we wanted to empower individuals in the community to take initiative in a bottom-up fashion. And we wanted to make sure that they were compensated for their contributions, but at the same time ensure that shared resources are allocated fairly and efficiently. And so we've been kind of experimenting with different like DAO processes and tools for quite some time. We tried like payroll style workflows, bounties. We had like some initial success with this like recurring nominations process where we distributed tokens on a weekly basis via like dot voting. We built kind of Dandelion because we were inspired by Moloch and Rage Quit. And what we kind of found is this sort of recurring theme as you get resources, like shared resources, and you get more people that have different like views on kind of what the most important thing is or what the priority should be. You get politics and kind of bureaucracy, and you get sort of like kind of fighting over like how things should be allocated, especially as you kind of maintain sort of that like culture of sort of bottom-up kind of initiative. And so what attracted to us like the concept of conviction voting was that you could reduce the argument surface, automate a lot of that process, and say if you create a proposal and it gets sufficient support, it'll go through. And that's basically it. You have the need to reach sufficient consensus and not like majority consensus or complete consensus for any action. And you also kind of get this guarantee over time that there'll be a specific kind of budget that's imposed. Things can kind of change gradually, but they're predictable. So you kind of align the incentives of the group in similar ways, but you can have lots of different initiatives happening in several different directions all simultaneously. So we were really excited about that. We started building like ETH Berlin last year around this time, and gradually we've kind of cobbled things together, and now we've launched our DAO on XDAI, like an MVP version of it, which is what you kind of see on the screen. And basically what this does is we have our like native community currency Honey. It gets issued over time into a common pool, which you see here. You can trade it on Uniswap or the Uniswap instance that we set up on XDAI. You can see the total token supply and also the tokens that are actively staked on proposals. And this is actually a list of like past proposals. But if I look, I can see there's 2 open proposals right now. One's related, well, I guess they're both related to Honey liquidity incentives. One to do development and one to do kind of research. And each one has a request amount denominated in Honey from this pool. And you have this little gadget here indicating conviction progress and requirements. So in this particular case, you're requesting 350 honey for this proposal. It requires 13% conviction to accrue behind it. So we need sufficient people to kind of stick over time to reach this. And so if I go in, I can support this proposal. It'll add conviction here, and it's sort of faint. So I don't know if it fully shows up on your screen, but you should be able to see we actually have two bars here. There's the conviction that's already accrued and the conviction that will accrue over some period of time. And so this actually says that it is estimated that it'll pass in about a day and a half based on kind of the current support and the like time factor of conviction. People can change their support. So like they could decide to switch their support over here, and it would require more support, or they could switch their support and it would reduce the support here and push it over here, but it would still take time to accrue. The other kind of factor is how much funds are available. So this is 13% currently. If I kind of click this hidden button here, which triggers the issuance function, which is like over time, it'll drop more honey into the pool, and I'll just kind of do that in the background. See that number kind of bumped up. There wasn't much since this has been checked, like clicked recently. So I didn't actually change the percentage required here, unfortunately. But sometimes that'll like drop down to like 12% or something, because the threshold here depends on the amount of funds available. So the more funds available, the more you can request. And the interesting thing for this is it creates a natural kind of cap on the amount of funds that can leave the org over time. Even if like everybody was 100% coordinated and supporting a single proposal, there would still be a time component where conviction has to accrue. And this allows us to have lots of different proposals on the table, but still have the same kind of guarantee that you get from, say, something like Moloch, where if you're participating and you don't like what's happening, there's like a limit to the amount of things that can kind of go wrong before you can decide to like leave or sell your tokens. So very, very nice kind of property there. The other kind of interesting thing I want to share is we've been running this like kind of pilot for about like 3 or 4 weeks now, and we've got a bunch of different proposals. Some of them are very different in terms of type. So like when we initially built this, we had some proposals to nominate people kind of for doing past work. So people that worked on this like MVP all submitted proposals. They had already done the work, and they were sort of approved after the fact, which is kind of cool. Then you have situations like the dev cred and social cred proposals that are funding initiatives that haven't happened yet. They need to be organized and developed, and in those particular cases, they would be distributing honey over some period of time. So if I like flip through and look at the proposal, this is actually requesting honey to be sort of delegated to a program administrator and then further distributed based on a source cred algorithm. So we can use the conviction voting as sort of our like consistent coordination resource allocation process, but have proposals which further distribute resources based on more specialized instances or different things, kind of like the liquidity mining proposal on the table now. So that's the kind of general overview of our MVP. We like want to add so much more to this, like proposal escrow, or adding like 3-box profiles, or the next kind of update is allowing like signaling proposals and effective supply, which I guess is sort of in the cadCAD model now. But the main thing is our philosophy of just sort of build it and test it. By doing it scales okay. It's really useful to have like on the ground things, but we're kind of craving having a bit more knowledge about kind of the mechanisms and the dynamics of the system. And that's why we're so excited to kind of see the conviction cadCAD model and sort of apply it to this use case, but also apply it to other situations as well. I think that's kind of the gist of my presentation. So I'm going to stop sharing my screen. I don't know if it makes sense to take questions later or bring them up during the cadCAD presentation, but
I think we should do 5 minutes of Q. I think we should do 5 minutes of Q&A on the sort of use case and the motivation. The next topic is going to be a little bit of an overview of the research that went into the conviction voting algorithm and what it is, and then we'll dive into cadCAD code after that. So I think practical application questions should come for the next 5 minutes.
Sounds good.
If anyone has any overarching questions about conviction voting as a process as well, feel free to ask those questions now as well.
As a layperson that understands voting in a general sense of majority voting, what are the trade-offs at a very high level in I guess the benefits, and how does it differ? How does conviction voting differ? And trying to understand kind of the ideal use cases to apply this type of voting scheme.
Yeah, that's a great question. At least in this particular instance where we're using it primarily or specifically for doing fund allocation. There's interesting research with regard to like how you can use the same kind of conviction process for other types of decisions, like setting linear parameters or just ranking things. But speaking specifically with regard to the like fund allocation process, the really nice thing is it serves the purpose of kind of budgeting as well as voting. So like you don't, the amount of like support that you need, kind of like a dynamic quorum, depends on the like size of the proposal. So that's very limited to just fund allocation. You can't use that same process for making an arbitrary like binary choice decision. But it's like specialized for that particular decision in a way that gives you nice properties, right? If you tried to do like funding decisions via majority voting, you have the ability to like send all of your funds based on a single vote, which can be really like really bad if you're like not the one that agrees with that vote, right? You don't have the kind of protection for minority participants. You also have this kind of concept of decisive voters. So there's the Barannesov, I don't know if I'm pronouncing that right, kind of index that's basically like looking at the power of different coalitions or individual voters to actually sway or swing a vote. And in the case of conviction voting, if you have disagreements over how funds are allocated, and you're a like minority participant, you can create a smaller proposal and still actually enact that, where maybe the majority position or some other coalition can go off and enact some other portion, and you get proportional representation across the entire set. Whereas in kind of more traditional voting, you really are only like representing the majority at any given time.
Right. Oh, that's interesting. I see.
Actually, I dropped something in the workshop discussion channel for you too. That was actually written by Jeff. That goes into a lot of more in-depth review, I guess, of conviction voting. That was helpful for me. Maybe that might be of interest.
If I could ask a dumb question, you mentioned before if a proposal that you didn't like, and you also referenced the Moloch, rage quit example. How does that? What happens if you don't like it again?
So in this particular case, proposals take a lot of time to pass, or they take some time at least, right? So like the amount of funds that you can use in a proposal corresponds to how long it takes to execute. So you have this kind of predictability in terms of like your risk, and you can choose to leave the organization if it is trending in a direction that you don't like. The kind of Moloch mechanism is you have proposals operating serially. So like when you submit a proposal to a Moloch DAO or a Dandelion DAO, it's added to a voting queue, and you process these kind of in sequence. And if a vote were to pass that you disagree with and you had voted no, you have this opportunity to rage quit before it gets executed. But everything kind of happens serially, and you get kind of that same sort of dynamic where, like, if you disagree, you can kind of leave before you're like caused too much harm by people that you disagree with, and it makes it easier to kind of collaborate. So in this particular case, you don't process things serially. Everything is open and on the table and can kind of pass at any time. But you do have a time constraint that allows you to sort of react to things that you may disagree with, and encourage people to like make proposals that the general group isn't going to find so distasteful that they want to rage quit, if that makes sense.
And what insights have you seen doing the conviction voting that are not obvious from the application? Or are there any surprises, or, you know, what has been written about conviction voting? Is there a difference in terms of like the practical application of it that you've seen so far in OneHive?
I think that like our data set is still way too small to draw any significant conclusions. But I think that like the nice thing is that like you can just put up a proposal and try and get support for it kind of after the fact. You're not like I've noticed in a lot of orgs, it's kind of like we have a specific voting timer, and something is going to expire, so you have to like rally the troops to get something passed, and you want to kind of make sure that like if you put up a proposal, you actually know that you're going to get support, because you don't want to kind of waste the gas fees, and there's like a time constraint and all of these things. With conviction voting, you can just sort of put up a proposal and it can be a signal in and of itself. And with the kind of the OneHive case, we're actually going to be upgrading our conviction voting implementation to include signaling votes as well. So you'd be able to make a proposal, not to request funds at all, but to just say, if somebody were to create a proposal in this kind of direction, I probably would support it, and I can actually like signal direction through that process.
Wow, that's interesting. And so with conviction voting, there is no expiration. There's like no downvoting, so things people don't actively vote against. They just don't vote for, and conviction is never held, or that threshold is never met. So a proposal in conviction voting could just hang on for a long time. Maybe it's not in favor, but let's say that same proposal is just there, and maybe is lower in the proposal queue because it's been there for such a long time, and then maybe a year later, so people like start rallying for it, and then it can pass. Is that the notion in terms of like conviction voting? Do I understand that correctly?
Yeah, so there isn't an expiration, and proposals will kind of stay on the table until they're like withdrawn by the proposer. So like if you created a proposal for something and you get really busy, you don't think that like you're that interested in doing it, you could kind of withdraw your proposal. In the future, we're actively working on making conviction disputable and integrating with like Aragon Court. So to put down a proposal, you would kind of stake a little bit, which would also provide the incentive to withdraw your proposals if you don't think they're going to pass, and kind of clean things up. So the intention isn't necessarily to have proposals stick around forever, but definitely it's really nice that and kind of by design that proposals are sort of approval only. And if you don't like a proposal, you're not able to downvote it. You can indicate that you like you can signal for other proposals, or just not signal at all. But you're slowing down the process. But you can't like veto somebody else's proposal.
And just to be clear, the mechanisms that are involved with conviction voting, we're iterating on them one at a time. So there could be in the future a vote against proposal, which lowers the conviction. However, in the interest of iterating on simple mechanisms and adding functionality as needed, we're starting with kind of the minimum features possible. I actually have another slide here that I'm just sharing my screen if anybody wants to see kind of a visual depiction of how conviction voting works. So we have here 3 token holders with various token holdings. They're asserting their votes towards a proposal X, and their votes kind of accrue conviction. So it's kind of like a capacitor or a battery charging up. So this is another way to think of conviction voting, is that you are voting, you can change your votes at any time. The tokens that are asserted towards that proposal charge up the conviction, but the tokens, of course, stay with the voter. Once the proposal passing threshold is hit, the proposal passes and begins the process. There's another way to look at conviction voting without this threshold, is kind of as a dynamic average consensus. So if you didn't have a proposal that needs to pass at a discrete time, this can be, say, a range of 5 to 10%. That could be, a community tax rate or a budget allocation to specific purposes. And this can be an ongoing dynamic average consensus of some parameter within your community. So there's a couple of different flavors of conviction voting as a mechanism and a tool. It's still, there's a wide design space here of ways that it can be used. And yeah, definitely still in the early days of exploration. So if there are any other questions on conviction voting on a high level, happy to take them. Otherwise, Michael Zargham can lead us into kind of the lineage of conviction voting and where it started and how it got to where it is today.
Yeah, let's just, I'm actually going to probably only say a moment about that, and then I'll explain how it works slightly more algorithmically before we dive into code, so that we don't have math questions while we're trying to do, let's see, share my screen. This one, actually, you know what, I'm just going to share my whole screen. It always gets angry when I present a slide deck. Do that, should be good. Let me know if you can see okay. I'm going. Cool. Now, still, now that I've screen shared the great DAO design workshop, conviction voting in cadCAD. I will take a moment and kind of talk about the history for a second. So I'm a signal processing and large scale systems engineer by training. I worked on all sorts of distributed and decentralized optimization algorithms of time varying systems as part of my PhD work at Penn. And actually, one of the algorithms I worked on during my thesis was a sort of integral style, leaky integral style accumulator of distributed information. And it worked quite well for the space of distributed optimization problems that it worked on. And I realized at one point that voting had a lot of really similar properties to that signal processing problem. So I'm actually going to take a moment and revisit the question of, what voting is. And for the moment, we're going to start with this sort of version 1 where it's a binary output, get past this or don't pass this. But to Jeff's point, it's actually originally derived based on something closer to a dynamic consensus or not necessarily a discrete output. In this case, we're going to talk about private, distributed, continuous, time-varying information that just sort of lives in a group of people. And their opinions are changing over time. They're making new observations. They're forming new opinions. Maybe they're talking to their friends. But ultimately, the preference over the outcome of this vote is really private to them. Even their actions might be slightly different than their internal preference, in the sense that maybe there's some signaling components to it. But ultimately, the preference is actually distributed across the community's participants. Those community participants can hold those preferences privately, even without acting upon them. And they can have continuous values even when things are discrete. Like how much I like that might affect my binary preference to support it or not support it. And again, those preferences can be time varying. And we need to solve a problem that takes that messy, time varying, private distributed thing and create a public centralized discrete event like this passed. Now, that's a pretty big leap, right? Private to public, distributed to centralized, continuous to discrete. And so that as a transformation process has a lot of baggage, and we don't want to do it haphazardly. So, I personally felt like we needed to investigate this and understand how to make something that would, solve this transformation problem in a way that was inclusive and, representative of those private, distributed, continuous time-varying preferences. So, to kind of continue on that, I had to ask myself how this related to signal processing versus obviously a policy frame. So we have these voting processes, which are algorithmic policies, which allow us to collectively capture the expressed preferences of individuals. Again, they have to find some way of transmitting their preferences, which are private, through some action, which will influence an outcome. But one thing that we have to remember is that this includes how one obtains and asserts their rights to participate. And I say including magnitude because in tokenized settings, we have the how much voice or voting power do you have, and that could be the same for everyone. It could depend on tokens that you've earned or bought. Again, that's actually part of the voting policy is, how one even gets and asserts that right. And here we assert them through cryptographic tokens, and we obtain them through some sort of purchase or reward process. And we have determined, at least in this use case, that you can have variable amounts, but you can still have something closer to a one person, one vote, in a sense of one person, one units of vote, one same set of units of voting, which there are other voting mechanisms that use this kind of distribute your weight across. Dot voting, for example, actually uses that mechanism. And so that's also an important part of the voting policy. Another thing that's really important is how proposals are added or removed. This is tricky because you have a lot of control over the system if you have a control over the agenda, the set of things over which one can vote on. And then finally, to the previous discussion, actually, there's no globally optimal voting process. In fact, because this is a high dimensional to low dimensional mapping, you always have to take into account context. What are you trying to accomplish? What does this community need? Which voting processes actually fit those use cases? And actually, when do you need to change them? When did they cease to fit the needs of the particular community? So kind of stopping and asking what a voting process is. Well, it's an algorithmic policy, and it's comprised of several elements. And so in the case of this system, I did a little bit of looking at what rights are actually provisioned here and used to participate in voting. Well, we can add proposals for consideration. Actually, right now, you can do that as long as you have an XDAI address. You could log in and just add a proposal. So it's now explicit tokenization. It's at risk of proposal spam. And the solution to that is largely community norms. But you can imagine blocking addresses, additional access controls, requiring another kind of token that gives you the right to participate, or having to have a minimum holding in the community currency honey. Any of these other options for gating are potentially necessary if we run into sort of proposal spam. But actually, presently, it's fine because it's largely the community norms that manage that proposal footprint. We have the ability to vote based on your holdings of honey. That's transferable, and it has magnitude in the sense that you could have more or less of it. The general attack vector for any tokenized voting is plutocracy. And again, we have community norms as our current solution. And there are other ways to further restrict this algorithmically if it becomes necessary. The introduction of strong identity would allow you to do things like fix the allocation of voting per identity. So say anyone who has more than X honey could get the same number of votes. That would be closer to a one person, one vote, assuming you could also sort of map those addresses to identities and avoid using something like Bright ID to avoid people getting extra votes by having multiple identities with more than the threshold. You can also imagine introducing a quadratic voting, or even quadratic conviction voting is a valid thing. It's a valid composition. Again, that would require strong identity. We talk about how to get paid to work on a proposal. Well, really, anyone who can be the beneficiary. You don't need to hold any tokens. You just need to have an address. What's the attack vector? Well, what if people don't vote for you because they don't know you? well, become part of the community. If people know who you are, you get an opportunity to do things. Future options that are algorithmic, procurement procedures, bidding, bountying, all options, and maybe they fit for different use cases. In terms of approving payouts, these are essentially automatic when a proposal passes currently. There's no explicit tokenization there, but the risk is that people take funds and skip out on the work because there's no explicit review process. But you can have escrows and independent review processes. Governance of this system, there's a sort of a second level of sort of tokenization in the OneHive ecosystem. It's essentially a council or group of people who have earned a sort of non-transferable, non-magnitude right to make decisions. And I'm pretty sure it's non-magnitude. I'd have to double check. Luke might have some comments, but I wanted to note that this sort of meta decision-making about evolving this is largely done by another sort of group of people who are sort of, I want to say leaders, but not necessarily in the way that we think of them in like a corporate setting. And I think that actually the presence of leadership type councils is a recurring theme in DAOs, and that it can do a lot as long as we look out for groupthink, deadlock, and people who are like sort of selfish in the sense that maybe they're not looking out for the community's needs, they're looking out for what they want. And you can actually address that through rotating roles, term limits, and other things that are TBD. And I just wanted to sort of wrap this with an understanding that there's actually a lot of algorithmic policies in play concurrently, and all of them are sort of up for discussion and composition. And one of the reasons why the OneHive work is so impressive is that they're exploring a lot of these things like a little bit at a time and putting them together and seeing how they work and trying to find this sort of grammar of like algorithmic policies that work together that alongside healthy community norms produce like a functional DAO ecosystem. And so in the case of conviction voting, this is one specific way of aggregating voting power. And to the question of like what it is and why are we using it, we have this idea of time integration, which to Jeff's earlier description means that the voting power charges up over time. It gives you visibility into where the system's going, which fosters discourse, allows people to change their mind. Like, imagine if Brexit had conviction voting. Instead of freaking out after the vote passed, people would have freaked out when the projections said the vote was going to pass, and it would have never passed because a lot of people weren't engaged because it just didn't really register until after it happened. In a conviction voting world, you would have gotten maybe in that case months in advance an indicator that this was going to pass, or that was with high probability would pass if people didn't change their minds or if more people didn't engage, and that would draw people into engaging and result in changing the outcome. So it captures the sort of collective intent in direction and magnitude and allows you to sort of change directions before something happens. This also moves away from synchronous engagement assumptions, and it reduces the attack vector of last-minute swing votes by whales. Another interesting note is that the time integration is actually linear, so it preserves any Sybil resistance that comes from token voting, but keep in mind that this is a sort of only really relevant if you're sticking to the token voting model. If you start to impose you can do quadratic conviction, or if you do sort of closer to one person, one pool of vote models, you don't have the you retain the linearity, but you have to worry about the Sybil attacks that come from creating multiple addresses to have more voice than other people. So it's a little bit of trade-off there. I make this note that there's sort of a half-life here. In this particular demo on the screen, it comes from this peer-to-peer models.github.io. That's a JavaScript app that sort of shows you conviction voting working. The alpha here is 1 minus 1 over the half-life. So it actually encodes the charging rate. And there's a couple different variants around where alpha is the same concept is embedded in alpha, but I think the coordinate transformation is slightly different, whether it's the half-life itself, or whether it's 1 over the half-life, or whether it's 1 minus 1 over the half-life. Kind of depends on how you've implemented it, but in all of those cases, alpha encodes the half-life information, is essentially as an exponential rate. Kind of getting into the assumptions baked into the algorithm quickly. We have participants. They hold some number of tokens. This is their right. Their right to participate in a vote. And they have some proposals which have some funds requested, who the funds were requested by, who's the beneficiary, and links to more information. But critically, the actual information about what proposals which participants appreciate are on a grid, right? Every participant may have a preference level over every particular proposal, and so their voting decisions are going to be made based on this private information. And this is a sort of a foreshadowing of what you'll see in the cadCAD models. This is a heat map that we made from the data structure that is used to define the sort of underlying preferences that agents use to make their decisions in the cadCAD model. It's key that these private preferences are heterogeneous and inconsistent because, to Luke's earlier point, there might be minorities who have strong preferences and majorities that have different strong preferences, and this voting system can actually allow things to pass in for both, maybe with different total funds allocated, but they would still both get projects that support their interests. The algorithm itself is going to be decomposed into a few steps here. I'm going to describe them briefly. The first one is that the individual agents make their own decisions about what proportion to allocate their support across the current available proposals. And they can change this whenever they want. So if a new proposal shows up, maybe they take some of the support that they were using for a different one and they change it. But ultimately, there's an inequality constraint that says that the sum of their support is less than or equal to their holdings. And if it's less than, that means that they have either some inactive tokens or we're moving towards a representation where there's a sort of null or signaling that allows tokens to be active without explicitly supporting a proposal that can pass because you're still conferring information to the system. But assuming the participants have all made their decisions, we can switch to looking at the system from the dimension of a particular proposal. And a proposal gets an amount of conviction, which is this driven linear system that accumulates the conviction over time from the support broadcast by the participants. And so this is our equation that shows the accumulator. It's called a leaky integral because it's adding up the sum over x at a current time, but it's accumulating it over time as well. And if alpha were simply 1, then in this case, y would just be the cumulative sum of the sum of the x's. By making alpha less than 1, we're letting some of that leak out, and that creates an equilibrium that is known a priori, that if it were to stay static, it would charge up to a specific point. But because it's time varying, this is a low-pass filter, effectively. And it's providing us a very, biological system-like way of integrating information over space and time. But with a very simple linear equation. This brings us to triggering events, and this is where the complexity that Luke was talking about before arises. Given each proposal has a particular amount of conviction at a particular time, and it has a sum of funds requested that was determined when it was proposed, then there's this trigger function, which evaluates whether or not you have more conviction than the required amount. And while this required amount equation seems a little bit complex, it's actually just a barrier function. It's saying that the most you could ever hope to take is beta % of the resources available. But as you get close to the resources requested is the percentage beta, the required conviction goes to infinity. So in practice, you can't get anywhere near beta. So if beta is 20%, we see that maybe 15% is actually viable with a ton of support. But in a way, this is it's like a electron repulsion equation, this 1 over the radius squared. And we repulse the attempt to take more than beta % of the funding pool. And otherwise, we have some correction factors. Rho is a linear factor that helps the deploy or scale this to sort of get to the range they want. S is the supply, or we've been working more recently with this as the effective supply, meaning tokens that are inactive because they're being held by the DAO to be paid out. So maybe they're in the resources available pool, then they wouldn't be in the effective supply. If they're on a liquidity provider, they might not be in the effective supply. The effective supply is meant to be representative of the tokens that are sort of in use by the community to make decisions. And that can be done by simply substituting S as token supply as S as effective supply in this equation. And the 1 minus 1 over alpha is a correction term that helps rebalance for the fact that our leaky integral sums up to bigger numbers when alpha is smaller, because it charges more slowly, and this is a normalization factor. So when some trigger function is passed, a proposal can basically eject its funds from the resources available, and they can go either directly to the beneficiary, or if it's implemented in a composition with another tool, for example, something like giveth, you could actually issue those funds into an escrow or structure that only releases them when, say, an approver signs off on it. But this particular component just issues them on. It's like a valve. And then finally, I'll end the sort of mini lecture by showing this is the early simulation from the first version of the conviction voting cadCAD model, where we show a bunch of participants on the left and a bunch of proposals on the right, and we see these charging up with conviction over time. They pass and they turn yellow. When they turn yellow, they're active, and then there's some time it takes them to complete the project, at which point they turn green when the work is done. It's a sort of visual representation of the time-varying graph that is internal to our cadCAD model. So with that, we're going to go into the coding workshop, but I wanted to sort of take a short moment for questions on the algorithm, since this is sort of what conviction voting is, before we have a look at the cadCAD models of conviction voting.
I have a question. Let's say a single participant decides to increase his holdings. He was already voting on a proposal, but then let's say he wants this proposal to go even faster, so he buys more tokens and stakes them on this proposal. So
he gets... this is actually the reason why S is in the numerator of the trigger function, because what's going to happen is as you increase the supply of active tokens, in this case, you're going to go out and buy them off a liquidity provider, for example, where they weren't active. When you bring them in and vote with them, they increase the supply of active tokens. So it creates a sort of like effect where it does benefit them. It might increase the percentage of the total active tokens that are broadcast for that, but it won't just allow them to sort of run away and pass something, because every time they do that, they're increasing the amount of conviction that's required. So they're going to have to wait for those tokens to charge up, and they're going to have to give other people opportunities to do the same.
That's a cool property. So the conviction that is added with these extra tokens that the participant bought is integrated over a different period of time as compared to his earlier tokens, right?
Correct. The tokens, when you add them, it starts integrating then. So if I go back to this example here, and actually maybe I'll just click the link. Can I open it? Oh, come on. Open link. Here we go. You still see my screen? There's a little JavaScript app running.
I don't see it now.
Let me figure that out then. I'm not. That's why I'm not broadcasting here. Let me go back to Discord.
We still see your screen, but it was just like garbled.
Gotcha. How about now?
Yes.
Yeah, I can see it now. I think there's a bit of a delay. It's kind of, garbling the screen up a little. So
Gotcha. So I'll try to be careful. Okay, so this is that JavaScript app, and if I guess it probably won't run amazingly well if I just run it again. But what you see here is changes in an individual actor's decisions. So in this particular example, Jeff has. It looks like at the beginning he has, or at time 30, he has a stake of 1,000, and then at time 60 he changes his stake to 7,000. So stake 60,000 more. You see how it's charging up? It charges up again. It doesn't start back here. It's a forward. It's sort of it's a forward integration. We're not sweeping the past. We're just saying, hey, at each time, how much conviction there is increments by an amount based on what each participant is broadcasting in favor. Does that make sense?
Yeah.
Cool. So we're already about 45 minutes in, so I'm gonna go hop into VS Code and kind of show you guys cadCAD model. Let me ask you first if you are able to see my VS Code. Can I get a verbal response from somebody?
Yeah, not quite yet. We're still kind of seeing it.
It's like loading in.
Gotcha.
Yeah.
I'm still working on using Discord as a presenting format, but
I can see it in the background of of your windows.
Maybe you just have to move the window around and it'll redraw.
Yeah, it's actually just small.
weird. It's taking up my whole screen right now. Actually, let me try. I'm gonna reshare. I'll try to share just that window since that's what we're gonna focus on now anyway. It's probably partly because I'm sharing my whole screen and not the yeah. So now I can
Yeah, I can see it better now. I actually think there might be some video problems for people who are using Discord in the browser. That may be introducing some video problems as well.
Gotcha. Well, hopefully people can see the screen now. I'm going to start to walk through this. So this is ongoing work in collaboration between Block.Science and OneHive to build some cadCAD models of the conviction voting that are tuned a bit more for sort of understanding and experimentation and iteration on the particular policies embedded in the models, and also to sort of mess around with different assumptions about behavior and how that affects outcomes. It can influence norms and parameter setting. So I'm not going to read through this whole notebook because I want to get you guys a little bit hands-on, but I'm going to give you a short walkthrough, and Andrew, who's been working on it, will give a more comprehensive demo towards the end. But for starters, there's a little bit of text introducing the same concepts that I just discussed. You'll recognize some of these plots from my talk. And there's also some Desmos here for trying to understand alpha and sort of iterating on this to make this notebook more accessible. But once we sort of hop into it, I think the first thing I want to go over before handing over the keys to let you guys play around with this is the trigger functions. We were just talking about them, so we can see that the trigger functions actually have a slightly different shape in terms of how much conviction is required, which is the color map, given the share of funds that you're requesting and the alpha parameter where it's set. And in particular here, you can see this red on the far right indicating the explosion of the barrier function. And the practical range is closer to this, 15 to 17% is where things start to become feasible to pass. And, it becomes a lot more realistic maybe to pass something that doesn't have massive support if it's closer to this, 2 to 5% range, or even smaller depending. We also look at how this relates to effective supply, and you can see here that if you increase the effective supply, you're also increasing the amount of conviction required to trigger. So per our last question, what's happening is for any particular proposal, say you want 5%, if you start going and bringing supply that you bought off a liquidity provider, you're going up this gradient and actually increasing the amount of conviction that you need. And it's important to note that these heat maps are log scaled. So as you go across the color gradient, you're increasing the amount of conviction required by orders of magnitude. So we have our slide on passing logics. This is a what we call a differential spec. It's a rough outline of the way the code works. We have driving processes which lead to upgrading the amount of funds available, as well as iterating on this network object. And this model is a little tricky. It's quite nested because most of the information is actually contained in a data structure which has this proposal's participant structure. So nodes of type proposal, nodes of type participant, and edges representing the support of the participants for the proposals. And so we're going to use a package called Network X to store data in a sort of graph nested JSON that it's not quite JSON, it's dictionaries, but it's like, you can think about it like JSON. And you kind of iterate through that object over time. A lot of this documentation is here available for you guys to look at, but I want to show you the sort of outputs of a particular experiment, and then I will show you a version of this where I've removed some logic, and we're going to kind of work together or in small groups to fill it in to sort of learn how to engage with these models. Important notes, though, model is made up of a state object. Here, the initial state object we've called genesis states. It's a network X object. It's an amount of funds. It's a sentiment, a sort of global sentiment variable, and a supply of tokens. Here, this is the effective supply for the purpose of this simulation. And we do a little bit of pulling data out of the network X object into lists of nodes, so it's a little bit easier to access things and look at them. So I pull out the nodes of type proposal, the nodes of type participant, the edges of type support. We have edges of type influence, which are actually relationships between participants, and edges of type conflict, which we are calling competitors. This is how we encode the relationship between two proposals that might otherwise, have the same goals, and maybe it's unlikely you'll vote for something if one passes that is trying to meet the same goal. So yeah, I would have preferred A to B, but B passed. I don't really want to support A anymore. I think there's better uses of our funds towards other initiatives. This notebook will allow you guys to sort of play around with these data structures once you get into it, or if you're already into it, you can grab different nodes. And here I've grabbed the first node in the list of participants and shown that they have a private, their individual sentiment, and their individual holdings, but otherwise most of the information is actually encoded in their edges. We've got their histogram of holdings, so I used a sort of tailed distribution to sample them from. That's available in the initializer. If you look in here, there's initialization. The initialization will a method that's in the helper functions, which actually produces an initial state. We have our plot of our social graph. These are just relationships between the participants. We have a distribution of funds requested in the initial proposals, and we have this initial grid of affinities. It tells us which participants support which proposals, but this information is actually private. We're going to have the agents make their decisions based on this, and we're going to see how the sort of game unfolds, so to speak, and what proposals end up passing at what time. We actually have this all packaged up in a config, this config object here, which is used in the run file to actually run the cadCAD simulation. And almost all of the social science, sort of computational social science simulation is happening in this engine in the background, which we call cadCAD. And it's basically taking instructions that are packaged up in these configs, and the output is these initially, actually, the output is a bundle of things. We're going to post-process them into a data frame specifically for the purpose of analysis. I'm not going to dive into too much in terms of cadCAD's raw outputs, but the key here is it actually outputs a handful of things, and we're organizing them into a data frame, specifically post-processing it for the purpose of this inspection. And we can look at things like the number of proposals that are candidates and how much funds are being requested and how much conviction the various proposals have at a given time. And we can look at things here like this particular run, we had an initial sentiment of 0.6. It spiked up initially. Presumably this means some proposals passed or got completed and it made people happy. Maybe a project probably failed. We have a notion in this model that projects can actually get funded and then not succeed, which tends to diminish sentiment, and you have to rebuild sentiment over time by passing and completing other proposals. And there's sort of a life cycle to this depending on the outcomes. Here we've got a rising amount of candidate funds. So this is the sum of all of the requested funds, not the requested funds of an individual proposal, and you can see it rising. And the total funds available falling as they get dispersed. Obviously, depending on the dynamics, you may also have funds coming in. They could be being minted or they could be being donated. It depends a bit on the specific application. And here we have this plot, which I think might have a little bit of a color coding bug in it because that looks a little weird. But there's a plot generator helper, which I'm going to have to check why it's so light in this range, though I guess it could be right, just a statistical anomaly. Worth double checking. But this affinities plotter is basically a method in the helper functions meant to show all the proposals and all of the participants over the at the end of the system. So how supportive people were of various proposals. So I'm gonna have to check in on the helper function to make sure there's nothing wrong with it here. And you can see this is a bit like a time varying pie chart where we can see the counts of proposals that were candidates. We've got new candidate proposals arriving. We've got active proposals staying kind of constant, actually, because some are being completed and new ones are passing. We have completed in green as this starts to get to the end. We've got purple for projects that became active but eventually failed, and we've got red here for killed. And killed kind of alludes to what Luke was saying earlier, that this is when some proposals were made but the community eventually decided one way or another that they're not going to support them. So it's implemented here as a minimum support. So if a proposal falls below a threshold that literally no one is supporting it or there's so little support, it comes off the list of candidates as a way of avoiding proposal spam and wasting people's attention. If it could potentially come back on if there's enough support and it gets reproposed as a candidate. But for simplicity here, we're preventing this massive accumulation of candidates by dropping things if they go too long without enough support. And we can look at that same plot with proposals weighted by how much funds they're requesting as opposed to just counts. And it's more or less the same shape, but you can see some increased variation caused by the variation in proposal size. And here we get a little snapshot of the system in the same view as the video I showed you guys earlier. And so that's a rough walkthrough, not crazy detailed, but I'm basically on time because what I would like to do with you guys is shift over into the workshop copy. And in the workshop copy, I've taken a specific part of this model in this system.py and I've removed the logic. And this logic that I've removed is particularly related to the way network effects work. It's 3 pieces of logic that I've taken out. One is the arrival of new funds. So obviously the system can't be sustainable if there's no new funding, whether it's coming from minting new supply or whether it's coming from buying tokens and donating them to the system to allocate. There's a variety of ways the funding pool or the resource pool can be made sustainable. It could be from revenues if you're building products that have some sort of recurring revenue model that can feed into the DAO that's actually supporting it. I have intentionally removed that logic so that you guys can put your own in here. The second thing is arrival of new participants. So obviously these systems have the potential to grow on the sort of labor side, and new people arrive and they maybe buy tokens and they want to vote, or they want to participate in this process by working and then getting paid in tokens and then following up with voting after they've arrived. or after the tokens have arrived and they can use them to participate. And finally, the arrival of new proposals. As proposals get completed, passed, or killed, etc., you need new proposals to have this ongoing evolutionary system. So, under what conditions do they arrive at all? So true, false. How many arrive? Do we see bursts, flurries of new proposals that compete with each other? Or are we seeing, one or two proposals at a time, and the group just sort of cumulatively decides to pass them or not and kills them and brings on a new one? Those are different dynamics that might be representative of different communities. And then finally, how large are the funds that they're requesting? And so we set this driving process up so that you can sort of describe those things, and then they get input to the other machinery here. That output is an input to this update network. It will sort of update the network X machinery and integrate that into the overall system simulation. The other place that people can play with things if they like is there's a range of parameters here. This is in the initialization. So we've got these beta, which is the hard max on the percent that you can issue, rho, which is the scale factor on the trigger function, alpha, which is related to the half-life. And this is one of the places where we're working on cleaning up the documentation. I find that people tend to get stuck on alpha because it also has this interesting phenomena that it works like an annualizer in like an interest rate type setting, right? You have to be careful about timescale. You might implement it on a timescale where it's updated every few minutes or few hours, but you might be reasoning about how fast it accumulates on, say, a day's timescale. So this particular model runs on a day's timescale. So if the internal parameter in the smart contract is updating more frequently than that, is triggered and caused to update more frequently than that, then you might need to do a rescaling in order to make the day period model line up with a shorter time frame smart contract. So there's some trickiness here. In addition to the time scaling, in addition to the sort of half-life versus rate-based interpretation. So can play with it there, see the result of the different alphas, and in our final version of this notebook to come out in the future, we'll have made it much more explicit which variation of alpha is reflected here and how it relates to the smart contract implementation. Finally, though, we have some other some other variables we use to control the sort of scenario that we've set up in a particular simulation. Like the base rate of completion is sort of how many days you would expect on average it to take, and there's a Poisson process hiding behind the scenes to determine when things pass. There's a base failure rate. Although failure is less likely than completion, if something hasn't completed, you kind of flip a coin to see if it's been completed yet, but you also flip a coin to see if it fails, and it's possible sometimes it will fail rather than get completed, and either of those is a state transition. There's a sort of state machine behind the scenes where proposals evolve from candidates to active to eventually completed or failed. Anyway, so here again, though, we're going to call an initializer. Since we have a pretty sophisticated state object, in order to generate one, we've got helper functions that will produce a valid initial state populated with n participants and m proposals and some amount of initial funds and some effective supply, and it'll sort of orient everything so that the system can evolve dynamically and just do a one step at a time update for each day, starting from a valid point. So that is the sort of topic of the workshop, and I'm actually going to start by going back to this place and kind of give people a second, ideally, to if you want to participate, to try to get to the point where you have this file open in front of you and you are sort of interested in kind of putting your own logic in here. And obviously, if you want, you can put the same logic in here that's in the other version, in the V2. You can find it in the same place in the system.py. So feel free to look at that as an example and to run the V2 version locally and see what happens as a way of working on this. The other option is to just go to the V2 file that runs and mutate it. So my goal here is to open this up to run it a bit more like a lab. So we're gonna like give us some time to just let people play with it. Different people can share their screens if they want to. I will answer questions. Other people here can answer questions. But this part is where we're switching to sort of collaborative workshop. And I'm hoping that by answering questions and helping troubleshoot and just treating this like a lab, people will get more experience and more comfort with using cadCAD for designing DAO processes and using it to model social systems than we might have gotten if I just continued to sort of present on the code. And any questions? Just sort of kind of taking the temperature. We're already like an hour in plus on presentation. We had 30 minutes before that of like setup workshop.
I have a question.
Sure.
About you said before, if a participant tries to put more tokens on a proposal and he gets these new tokens by buying them, thus increasing the total token supply. But what if he got these extra tokens from and these tokens were already created beforehand and they were just sitting on an exchange somewhere? So that would really push up the time scale when this would pass, right?
Yeah, so this is an important nuance, and this is part of what we're actively working on in factoring the models for the learnings from working with Luke and OneHive, is that moving away from just supply to effective supply or active supply, because we know that at the contract level, right? You know which tokens are actually being staked or have been staked within the last X period of time, or like you have a way of saying that these ones are in use or in use recently, and using that as the value of supply in the conviction voting trigger function algorithm, as opposed to using the true total supply, because that will exclude things that are in liquidity providers or on exchanges because they haven't been used in active voting. So there'll be a difference between me unstaking some of my tokens and then selling them to you and then you staking them. Then the effective supply has stayed about the same because the same tokens are being used for voting. But if the tokens are created and made new, they've increased the supply, but maybe they're actually sitting in this resource pool to be allocated as project payment, in which case they're not active, they're just there. We wouldn't want to count them. Similarly, things on exchanges or in liquidity pools. So the nuance here comes from identifying an additional policy that says which tokens count as effective or active. And there's actually some nuance there because honestly, you could pick that protocol differently. You could say only things currently staked count, or you could say, that things that have been staked recently, or things that are held by addresses that are actively staking anything. These are actually different policies. They have the same effect. They kind of go for the same reason, but they might actually turn out to have different dynamics in terms of the community. And so some of the experimentation over those policies is the kind of thing we would want to do with a cadCAD model. Does that help or make it worse?
Oh, yeah, it's great. Thank you very much.
I'm never really sure. Sometimes I'm afraid that my ex make things more confusing, not less. So I want to really encourage sort of collaboration and like trying things out. So I'm gonna pick somebody and put them on the spot. Hey, Barlin, are you still here? Matt Barlin, still here?
I'm here. Yeah, I was here. I was trying to find the where I was. I'm here.
So I was gonna say, if we want to like have little working groups, I mean, Barlin can probably help with one. I can help with one. I think we may have Andrew here. Andrew from Block.Science, who had been working on this. Not sure, but if he is, Andrew, are you here?
Yes.
Cool. So what I'd like to do is actually try to use this awesome Discord space to like let people kind of break up into little groups and actually try to hack on this. So I'm nominating each of you guys to be a sort of you know, I'll say like question answer or helper, and let's like try to start to organize towards like group sessions. So if you want to sort of hack on this in a small group, then let's have you like join up with one of these two guys, or I will probably float to start. But if we need a third group, then I will do a third group, and we will try to let each of those groups kind of make their own decisions about what logic to put in this part that we've removed. As I really want to try to get people doing this themselves. Jeff, do you have any suggestions for how to manage this? I'm comparatively new to Discord, or maybe Beth does. I not sure what's the right way to give people a breakout space.
We have these two other voice channels below, so if you break out in there, feel free.
Cool. So I'm going to see if I can drag Barlin. No, I cannot drag Barlin. So let's have Barlin grab the Hacker Hangout and Andrew grab Demo Day, and let's try to like just sort of break up into two groups to start. And if it's still too heavy, then we'll try to break things out more.
That sounds
I
good.
would split the rooms down the middle. So if you're above Proof of Tom, go to the Hacker Hangouts, and if you're below, go to the Demo Day. If that's half.
Oh, there we go.
And which one should I stream?
I think you should pick one and work in it and just stream the one you're in. I think that would be fine. I'm pretty stoked to see what comes out of people just trying this out, and I think it'll be an interesting experience to see the effort to agree on like what logics to put in.
Sounds good. And there's nothing going to be happening in this one?
Yeah, I think not. I think we'll come back to this one to do demos. What I'd love to see is each of the two groups showing their notebook at the end of the time slot. And we can do that here, and we can stream it.
Sounds good. Yeah, so for whoever's still here, pick one of the rooms below.
Sounds good. And I can hop between channels and make sure people are back in this channel by Q2, do you think, Z? Should we give people about half an hour and then 15 minutes at the end to wrap up back in this channel?
Yeah, I think that should work. I'm.
So I was kind of half paying attention while I was actually kind of looking at. I didn't want to cheat and look at the at what Zargham and Andrew were doing, so I was kind of making my own version. So just kind of walk you through like a little bit about where I was with it is. So you know, this is also kind of like the cadCAD workflow a little bit. If you look at, so I'm sorry, I should stop. And can you guys see my screen, by the way? Are you seeing the VS Code? Okay, perfect. So, I think I went too far. Yeah, so typically right around here, this is where we run our simulation. And if I just, one of the tricks by the way, is if you're in a notebook, if you're making a change to the model, it's going to essentially that the config, what we call our config, does need to be you need to like restart your kernel, otherwise it won't take into account new changes. And I know mine isn't going to work right now because I'm in the middle of coding it. But actually, because I didn't save my changes, I'll have the original error, which we'll see here. And let's see. So let's have it come up when it gets here. And so when it gets here, should be going faster. Okay. So we're going to see the original error right around now. Okay, so yeah, so right here, was there? It just jumped. Yeah, so like I said, from kind of a cadCAD workflow, we see that there is the error is actually in here. Right. And we'll see the error here, and so like my first clue is that we see. Oh yeah, I was in the middle of running. Okay, so the original error was that new participant was not defined, and so that was like, okay, so anyway, and that was the part that Zargham was saying we needed to work on. So a couple cadCAD things. Yeah, I was in the middle of writing it. But so a couple of cadCAD things. So if we're adding a policy, we output policies as dictionaries here. Okay, and so one of the things that's a little you have to be like pretty aware of is that if you're outputting a dictionary, and so typically we have a key and a value, then that value needs to be something. So like, for instance, if we're doing like if statements, then we need to kind of cover the other end of the if statement if that's writing to a value. So then we have to have the kind of the else side handling it, the opposite case, or like having nothing happen but still make that nothing be something, like it can be zeros or falses, etc. So that was kind of just where I was at, and then I was kind of playing around with, okay, what would be how kind of randomly putting on a new participant, and I was gonna really look more at what funds would be coming in, or like I was really kind of focused on the proposal side. So that was kind of where I was, and then I'll let you guys. So does and more people joined. So does anybody have any questions about that? And then we can kind of start talking about where we want to go with not only, we have kind of three things that we can kind of think about, right? Like, how do new people come on? How much do they have? And then how do the new proposals happen? And how are they kind of set up?
The first part was arrival of new funds, right? Not necessarily people.
Correct.
Okay.
It's funds. Well, I guess the order that they're written in, but it's people having funds. So people, when they arrive with funds, but there's a separate bullet for funds arriving in the pool. So there's a difference between funds and people. Arrival of new funds in part one means that new funds are coming into the pool to be allocated. So in your case, you might say that this could be thought of as a minting function as opposed to thought of as a donation. Like the original conviction voting model assumed X die, and it was like a donation externally versus the version of the model where it's honey, and that honey comes into existence through a decision by the community to sort of mint more of it, which obviously has ramifications on its price, depending on whether those funds immediately find their way to, say, a Uniswap instance where they would be used to withdraw another asset. So like, there's a lot of coupling going on. But for simplicity here, you could still make it a minting rule. We don't have the Uniswap dynamics in the model, so we don't have to worry about this depressing the price.
Yeah, so we could pretty easily make kind of a minting function where we could do something like this, right? And let's say we already have funds, so let's see.
I don't think it's worth trying to put a bonding curve in there.
Okay.
We don't have enough time. I see where you're going with that.
Yeah, it's kind of on my mind these days.
I mean, the model that we're using for honey it's just issued per block or like per time period as like a percentage of the supply.
Okay, so new. Oh, okay. So as a
percentage of the supply is fine.
Yeah, so that's kind of what all right, so that was kind of what I was thinking here, right? That we could, it won't be new participants. So new funds, is that good? Yeah, so that's funds arrival. Yeah, okay. So that's going to be funds arrival. Yeah. So that works.
Yeah, then literally that's sufficient, right? Like if you set that variable, because everything else is plugged in. So if we set a policy that says funds arrival is 1% of the current funds, next time funds will be 1% bigger, and then it will arrive 1% more. With the caveat that that is an exponential growth, so you might want to make that a smaller rate.
Right. Yeah, good.
This is per day. Remember, the model's timescale is day, so this is an exponential rate per day. So the so that's now one.
That's 100th of a percent.
A basis point.
Yeah.
Yeah, so that makes sense. So that's 1 basis point per day. The time scale for our simulation isn't that long, and that policy should work. So that would cover part 1, actually, if we wanted to do that.
Okay.
Is it funds or is it supply, though? That's not...
So now here?
You need to, it's a percent increase in supply, not increase in funds.
Okay. Yeah.
If you're minting to the funds?
You're minting straight to funds. But is it a percent? It's an amount that is a percent of the supply, though, right?
Gotcha.
Or is it a percent of the funds?
Oh, gotcha. Yeah, it would be a percent of the supply.
Right.
But do we need to separately increase the supply then?
Yes, we do.
Yes.
Because this model had a fixed supply in the way that it's currently written. But actually, fortunately, you have Barlin who should be able to do that for you quite easily. It means that there's a second mechanism, which is basically just exactly the same as increment funds. It will be increment supply, and he'll be able to add that to your partial state update blocks.
Right. So that's. But if this is funds arrival as a function of supply, oh right, and then we're making.
You don't need another output because it's the same output, right? Funds arrival is going to be the same output variable that you input to increment supply. So you should just copy increment funds, call it increment supply.
Increment supply. Yep. Yeah. So is that the same? But it's the same rate.
Yeah, it's 1-to-1. This isn't this model, the one hive model, the reserve and the supply are the same token. It's honey that's in both the supply and the funds. So actually another thing to check is to make sure that the initial conditions are such that the funds should be strictly less than the supply. It's one of the things that we were working on with this model already was switching it over from an XDAI funding pool to a Honey funding pool, which means that, for example, the funds are inactive tokens. They're not part of the they're part of the supply of tokens, but they're not part of the active supply. So to be honest with you, there's like a bit of refactoring embedded in this model to be done, specifically to make sure that the accounting makes sense. But actually, I think this is a really good thing for us to work on with our time slot. So I'm going to recommend we continue on this track while then maybe using the same logic for the other two that, if we run out of time, we can use the same logic for the other two that's in the existing code. I think I'd rather do one thing carefully than three things haphazardly.
Yeah. Okay. Yeah. So I mean, was everyone paying attention? Oh yeah. Whoops. I gotta change that. So yeah. So I'm adding the state update function here. I think I got everything here. And then I'm also adding it to the partial state update block. I should go slow in what I did there. So what you do in the partial state update block, you're naming the state variable that you're going to update with the function that updates it.
Function, you put an extra P there, so that's not going to work currently in the function name at the bottom.
There's two P's that yes, gosh, gotcha. Yep, because I did it backwards. So I wrote the function again. Okay, so I think we handled that. Yeah, this first part. I think, let's see, supply, funds arrival, supply, the function of supply. Okay, yeah, so then we do have to handle new participants and arrival of new proposals. So, let's say, so do we want to just use what they were looking at, and let's see if it integrates. Oh, it's bright. So let's see, expected holdings. Yeah, so okay, so pretty similar to what I was looking at doing. How does this work?
You can look at it in VS Code. I separated it into separate folders. So you have the V2 folder and the V2 workshop folder. The code is still in the V2.
Yeah.
That way, if you want to look at it, you can take it, you can change it. And if anyone wants to contribute suggestions, I mean, the point here is that the social part of these simulations, we really, in real life, we don't really know. So we have to have the capacity to experiment and try different assumptions, even if the parts of the code that represent the core algorithms are staying the same, we're modifying our assumptions about behavior.
So then you can just grab all this. Yep. So just grab all of this, we can see what happens. Yeah. Outside of the funds arrival. Okay, so let's see. Yeah, okay. Get rid of that. There's stuff I was playing with. So I think this could work. We'll find out. Let's see. Well, it is running, so this is a good sign.
Yeah, I think it'll be good. It takes a little bit. Currently, we're working on some performance improvements and environments that allow things to run faster. But right now, one of the main reasons it takes a little while is because our state objects are quite rich. They're these
right, because it's called Network X objects. Yeah.
Network X objects are kind of big, and so we generally use them, but we use them when we have this networked information. And it'll get better if the data is sparse, variety of other ways to work around it. But if a lot of models, if you don't have an embedded network object, this will run a lot faster.
Running, what I would do next if I was building this model, is this part that we actually worked on and did this fund supply. What I would do next is I would take out this value and make that a not only obviously a variable, but then I would bring that variable into our parameter dictionary, so that way we could actually run a test against against like this kind of like minting rate that we just made up. So that would be like kind of the next thing I would do while this is.
And you said earlier that like because the model was assuming XDAI for funds, but we're now minting funds as part of the supply. Is there a mismatch there? I noticed in the main model it was looking at funds in terms of XDAI.
Yeah, that's one of the refactors underway for the next version. So we kind of did this halfway between sort of V2 and V3 because we had multiple versions of the model as we've sort of iterated through making it more accessible for the broader audience. And so the workshop kind of fell pre-version 3, if that makes sense. So yeah. We're actually right now we're doing an experiment with Barlin helping lead where we're showing what it means to sort of change how we interpret this. Because we're now interpreting it as honey by defining it as minting and binding the creation of new funds as being equivalent to creation of new supply. That's literally the act of refactoring it to represent honey instead of XI.
Okay, here we go.
So there's a bit more to it, but it's the crux of it, really. We have to also have the effective supply refactor to make it make sense.
Straight line for funds expected.
Yeah, that's not quite right.
Right?
Is nothing passing? Because can you scroll down? It looks like you're not seeing anything pass. You're accumulating lots of proposals, but here we go. What do we got? We've got candidates. We've got killed. And for some reason, we created a scenario where. I think this is actually what I was just saying. So I bet what happened is you blowing up the supply, and because we haven't added the effective supply refactor to this version, that means that the required conviction to pass is out of reach because so much of the funds belong to the DAO. So you've actually reproduced exactly the case that led to the discussion of effective supply. If the DAO holds a bunch of funds, then nothing can pass.
Right.
So, that's actually kind of cool that you did that because so
all right, so now
good job. No, I mean honestly, that's part of the reason that we do this, because now if you hadn't yet thought of the effective supply fix, you now know that you're going to need it because you quickly, if you analyze the results here, realize that the growing supply is actually preventing the community from passing proposals.
So
You also have to make sure that you're getting your supply into the funding pool, because it looks like you might be missing that as well. If you had a flat line, it should have actually been going up.
At the fund, so yeah, so back
go back
here.
to that. There's two things we need to see different. One is that we want to see the funds going up. It's okay if nothing's passing, but it actually might result in things passing some, because if the number of funds is going up, the percent of funds being requested is going down, which is reducing the conviction required. So the first fix is to make sure that the newly minted supply is also incrementing the funds correctly. And that the second check is if we're still not getting anything passing, we want to go make sure that we have an effective supply, not just supply in our trigger function.
Gotcha. So the funds are going. So, but you had funds were going up in your. Let's see, funds. But you're saying that there should also be additional funds as a result of supply. So would a simple kind of test here be that the supply can increase at the same rate as the new supply is an increase at the same rate as new funds?
Are you asking me or
someone? I don't know.
Yeah, the group. I mean, this is like we're deciding what to model, but as I understand it, yeah.
Okay. So we just had we started with I want to do a curve, but instead, if I just do a heuristic that says let's mint half.
If we mint half but increase funds by more, are we saying that there's also donations, but we're not?
Right, that we're that essentially some of it is going towards essentially the project.
Wouldn't adding that division that you just did how is that going to if we weren't incrementing funds in the model, it was a flat line, wouldn't that if anything make things worse?
Yeah. Right, it's the opposite.
Is it not added in our state update block or something? For increment funds?
Yeah, it is here. The driving process, and then so what we can do, we should see. That comes out of funds arrival. Here's what I'll do. Let's find out. Oh, it's running. Hang on. Yeah, we have some results, but hold on. I hate it when it does. it overrides. Okay, so this was my kind of hack at it to get okay, so now funds are going down. Okay, so that's
They're passing. It's good.
yeah. We have an active count. Yeah. Funds, killed funds. Okay, so that did do something. That's good. Funds are coming down. Yeah, okay. Right, so now let's do it. All right, so we did have, I was gonna do a test to see. Just so you can see, like, pretty simple. If I just did this. That'll just be a check, and then which we don't need, but let's just do it since I did it. And then let's take a look. So what if? So we were increasing. So here's what I think I want to do. I know it's already increasing, so if we increase it, the supply at that same rate, again, knowing that it's multiplied. So it's basically, oh no, but that's not gonna work because
I think it is. I think it's just really small. Is it possible that you're just increasing it at an exponential rate that's so small?
Yeah.
That feels weird. It seems like it should be bigger.
Did you see, like, this was the version when I just made it divided by 2 for supply, the supply increase.
That already looks better. Huh.
Yeah.
Yep.
So it's interesting that the only that it was just that 1-to-1.
Well, it shouldn't. Yeah, I feel like there's still something a little strange then. That doesn't. It seems like funds arrival. So you have your increment supply. Oh, no.
This is what we ran. What you're looking at was this.
Why is there the times? Isn't it just supply is the fund plus funds arrival? Like without the 2, it didn't work.
That's what we started with, right?
Yeah, those are the first results we started with. Where the first results you saw were.
Yeah, no, I understand. I'm trying to figure out whether we missed, like we overlooked something, because it seems like that should be fine. That's literally. I feel like it's more likely that we had a bug and that something's canceling out.
Yeah. Well, so then, so what I was, just gonna track and see what the fund arrival will look like, because it could be.
Why don't you go look at the initialization file for a second and double check the scales of those variables, because I feel like the numbers were off, right? Like we should have supply, and we have where's initial funds, right? So their initial funds is bigger than supply, which is wrong. Right. Obviously. It can't be the case if the supply is a superset. So why don't you just try changing the initialization? Like that was that you had the parameters set for a case where the funds were in a different unit, not where the supply is a greater set than the funds. So just cut the funds down by 2 orders of magnitude.
Yeah. Yep. Was it 40? Okay. Oh, come on. There we go. Wait, and let's make sure back to there. Okay.
So
Does anybody questions? Go ahead.
I was saying, I think we're using the actual like honey supply somewhere. So if we made the starting funds, the like current funds, it would be pretty close to.
Yeah, I think this is why I think it's funny that this ended up midway through a refactor, because I think that 48 is just 1 0 too many. If it was 48 with 2 zeros, not 48 with 3 zeros, it would have been pretty close.
Well, the reason for that is also that right now 1 honey is 10 XDI. So if it was in XDI terms and it was just using the funds available,
that
would also make sense.
Yep. I think that's probably
why
why.
in honey funds are in XDI.
Right, but we're refactoring it so that it's all in honey, because the model that we're modeling is honey. So if you're minting honey, not XDI. So yeah, but I see the point. The idea is it depends on what as measured in XDI. Then okay, so this is working, but it hasn't gotten long enough for them to complete. But it seems to be working.
So just to throw out another kind of question, for the sake of having questions, we're going to be preparing like a conviction funding pilot with Aragon, and it'll run for like a fixed period of time, like 6 weeks, and have like a fixed like starting pool of funds that won't get added, and so you wouldn't have new people, you wouldn't have new funds, but you would want to parameterize like alpha and stuff like that, so you'd have a sense of like how what proportion of the funds is likely to be
disgorged.
Yeah, exactly.
Yeah, and it's actually, this is a thing that maybe a good thing to do at this moment is chat a bit about testing grids, something that we're not currently doing in our project on conviction voting, because we're really just working on this like model, refactoring it for single runs. When we do testing grids, and Barlin does a lot of this kind of work, we create specific scenarios that represent both the mechanisms and the case. For example, this 6-week program, and we'll run experiments specifically for the purpose of tuning parameters based on arrangement assumptions. And so actually that's something that we'll probably want to make a tutorial about sometime soon, and we may well be able to build off of this, where right now a lot of the effort has actually been around constructing the honey specific variation, and then really just fleshing out the documentation, which turns out to be a lot of work. like I think this is true in every engineering or field. Like documenting things is like about the same order of work as doing them, but it's really difficult to like make the time and the prioritization for that part. Anyway, I think we probably have about 3 more minutes before we want to regroup with everybody. So
yeah,
in terms
I was just looking at the workshop though. This is kind of everybody.
Yeah, I think everyone is filtering here.
Oh, cool. Welcome, everyone. So, I mean, what I wanted to do was give each of the groups a chance to like talk about what they did, why they did it, and what results they got, both in terms of like seeing things that they expected, seeing things they didn't expect, maybe if they hit some bugs, what were they, like what learnings did we take. I'm going to maybe put the other group on the spot since they're here, and I'll let Barlin finish trying to get a run of the logic that we made in this group. And then Luke and Barlin and anybody else in the group who was participating can kind of talk about what we did and why. But in the interest of having pretty plots that Barlin is trying to fix right now, I'm going to let the other group go first. So I don't know if you want to, we can hold the share and switch over. It is the other group.
I can just talk to it straight away. We found some beautiful code found not in the workshop V2, but in the original V2, and we seemed to got that to work instantly. So that's We just spent the time going through and understanding and just stepping through the code step by step. We didn't go too
That's
fancy
fine.
other than that.
I wouldn't mind. I'd love it if somebody who's not one of the people who helped write that code wanted to screen share and show us what you guys talked about. I am mostly trying to use this session to help people get comfortable with it for themselves, so they don't need, me or Block.Science or any of the engineers that we have. We just want people to be able to do this kind of stuff because it's interesting.
I won't screen share because I didn't pray to the demo gods today, but one of the things that I kind of got through by looking through your code is basically like why you actually go through some of your modeling processes. So, for example, we went down here to the expected holdings. So here you use an exponential function, and one of the questions in the group was, why do you actually, pick an exponential? And what we were told is that you kind of go through and, modeled existing contributions and, whales or whatever else suggests that, you have an exponential function that kind of fits how people fund these things. So that was interesting.
Yeah, I think probability distribution choices are super important. I don't think they're ever like final, ultimate, like useful for all cases, but exponential functions are pretty good for tails. They're not necessarily the same as totally fat tail distributions, which is another family, like power law distributions. They can be good sometimes. There's also gamma distributions, which give you a slightly humpier. They're like 2-parameter distributions, so maybe it's not like super small, but there's like a kind of an average, and then it goes up and then goes down. And you'll see a lot of exponential. You'll see a lot of gamma, occasionally power law distributions arising in our code because the experience with the sort of complex systems, network science, data science kind of lends you to see a lot of social systems in statistical form, and you start to get an intuition for which shapes of distributions match to what types of phenomena.
I think that's it from our group, to be honest. We actually just stepped through some of the code. We went through the example where we changed the K and we printed about the different plots. But essentially, we just went through the existing code. So we'll hand it off to your team.
Cool. So in our group, Barlin sort of led on the code, and Luke kind of led on the discussions of like what kind of concepts to change. And I'm gonna give them the floor to talk about their experience. I tried to help, but I'm loud. I talk too much.
So I can go with kind of what we did was we tried not to cheat at first, like the other group did. No offense, just kidding. And so what we did is the only change that we focused on was the arrival of funds. So it started with a very simple, essentially growth, exponential growth rate of 0.100%. So or E, lowercase e, or K, I guess K equaling that amount. And so just kind of working backwards a little bit. So that was our funds arrival. And then so I added a state variable to also just track that so we could see exactly what that was here, and then a function to track that as well. So essentially the funds arrival just directly output as that, so we can see what's happening there. Because obviously, like, this was essentially our change to what is already there. And with that, we also added that to the supply on a 1-to-1 basis as well. So here, and then I can kind of let Luke discuss like kind of what's happening with the count, with the counts, if that helps.
Yeah, so when we did that, we ended up seeing like a bunch of candidates and a bunch of killed proposals, but not a lot of things passing. So like that nice colorful chart was mostly red and blue. We spent some time kind of trying to figure out why that was the case, and ended up adjusting the like starting funds amount to kind of like adjust that. I don't remember exactly what the outcome was when we changed that. If it made a difference, I don't think it ended up making a huge difference.
It made, I noticed, a big difference here on, obviously, because we started with the funds now much lower, and now the candidate funds were now coming in.
Gotcha. Yeah, so we saw our like candidate funds start to increase, and then stuff would pass and then decrease. I don't know if there's a separate parameter for like the average fund request, but it seems like there's a lot more candidate funds now.
Yeah.
I don't know if that's because we changed the like decreased the starting funds by like 10.
Yeah, we didn't write that part, so that was one of the parts that I put in. The I guess with when I wrote up the things for people to write workshop, I probably was thinking too much like a engineering lab where you have a couple hours to play around with things. And so we kind of came in and we started playing around with things. We kind of picked one of the three things and worked on it, but the other things I had flagged to work on included deciding when new proposals arrive, and that includes deciding how much they ask for. So that is something that's part of the model that's parameterized. It was just one of the parts I had hoped people would get a chance to play with.
Cool. Sure. Good.
But at least from my perspective, the thing that stood out was that when supply and kind of putting it in the funding pool, we actually recreated an issue that you and I had discussed some time ago related to the supply getting big and it being difficult to pass proposals because the amount of supply actually affects the proposal trigger, like passing logic. And without actually refactoring this model to include a separation between the total supply and the active or effective supply, we would very much expect to run into a scenario where passing proposals is hard because you can't get enough conviction because the tokens are not actually being used to vote. So if you don't actually account for a subset of the supply that is being used to vote as different from the supply that's either in the holdings of the DAO itself or in the say exchanges or out in the world not being used, then you're going to end up with bottlenecks because that you need to have enough conviction as determined by the supply. So this supply versus effective supply is a thing that you can learn from doing the simulations. Like if we went to start minting supply in real life, we would know that if we did this without also changing the way the trigger function worked to have effective supply, then we would expect it to be very hard to pass things. So we get red plots.
Yep.
Red plots are bad. Anyway. So, I mean, this is the time that we had. I appreciate people coming. I suppose that we've probably kind of slowly reduced our pool of people over time. But I hope the people who stuck around found it informative and that they, I don't know. If there are more questions, feel free to stick on and ask them. But I appreciate your attendance and I hope you learned something.
Yeah. I'll say the same thing, and hopefully the people in my group learned something too.
Definitely. And while we were all hacking in the VS Code, I think I also managed to get Google Colab set up to accept the file structure that we have in GitHub. So when we do this again in Google Colab, we won't have to copy and paste all of the supporting files into the one notebook. We can just use the same file structure.
This is really cool.
Cool.
Definitely enjoyed it.
And thank you to the metagame folks for their sort of support and sort of help. And yeah, you know.
Thank you for doing this. It was great. I think this was probably,
Thank you, folks. Thanks, Marlon.
if not the most successful workshop in this hackathon. Didn't expect so many people, to be honest.
Nice.
Yeah, we filled
And I
up
think a lot more will.
channel. That was cool.
I'm so I realized the time zone wasn't the best even because I know a lot of people who had reached out were, you know, a little further east, and you know, maybe next time we can try to do something earlier and actually get more people.
Yeah, it's 2 a.m. here.
Yeah, it's pretty late.
Oh.
But there's definitely a desire for them, so yeah, I think we'll continue to get people showing up.
So
Awesome.
so thank you.
Thanks, everybody.
For coming, and thank you for
Thanks, guys.
Thank you.
Chat with you next time.
All right.
See you, everyone.